GLM, repeated measure. This is the last topic under group differences and factorial design. So we're going to learn one-way repeated measure ANOVA analysis today. So repeated measure ANOVA, chapter 15. ANOVA, when we are doing ANOVA analysis, it's between groups, right? But repeated measure is within group and the same subject, the participants repeat the trials. So that's why it's repeated. And we learned a similar concept when we learned the paired t-test. That's exactly same concept, but this is more than 2 repeats. That's what we're doing, one-way ANOVA. One-way repeated measure, one independent variable repeating. Two-way repeated measure, which we're not going to cover, but you have materials to self-learn, and you have two the conditions, independent variables that participants repeated. In one condition, repeat, another condition, repeat. Or repeat itself could be time, pre, post, and follow-up, then male and female, like that. There could be a mixed model, so which we're not covering here, which is GLM5. One IV repeated, another IV is between. So it's a mixed model, is between and within subject research design, which is absolutely possible depending on your research question. That's a GLM5, not covered in this course, to give you an idea. All right, so let's just go straight to repeated measure ANOVA assumption test first. There should be no significant outliers in any level of within subject factors. Number 2, normality, each level, again. Approximate normality is fine, like we learned through other ANOVA analysis. And the last one is homogeneity. It's not the same homogeneity that we have learned. It's another new concept in repeated measure. It is called sphericity, which means the variances of differences between all combinations of levels of the within subject factor must be equal. The way they measure it is differences between first repeated measure, second repeat differences, then first, third, first, fourth, if it's 4 times, then second, third, second, fourth differences, third, fourth differences. That differences has to be equal. And in SPSS, it automatically tests using Mochieli's test of sphericity. So you don't have to worry about it. You need to learn how to interpret that. So that's the goal of today. So I want to learn more about the data. So here we go, SPSS step by step. It has data information there. Total participants, 8 people. And they were forced to eat 4 different yaki animals. And so repeating 4 times. And the dependent variable that they measured was the time to retch after eating each animal. So they ate stick insect together, kangaroo testicles, and fish eyeball, and witchery group, which you have a picture here that they're eating. And 4 times, and then as soon as they eat it, they measured how long it takes to throw up. And that was a dependent variable. All right. So having that said, we're going to do step 1, 2, 3, 4 using the data. So first step, calculate mean and variance across conditions. So you go to transform, compute. If you need this one, then you can do it. I already made a target variable name. I typed it in. And the mean scores, you go to statistical function, and then click mean. Then a mean will move to here, then add all 4 variables there, and you paste it. And I'm going to say okay, then you will see this was actually a syntax file, how to do it. And then do you see that mean score came out? Then we will do another one, variance, which is just step 1, 2. Variance. Then instead of mean, you put here, you can type in, or you can click from variance here. Variance. Then you say, okay. Then see that another syntax popped up here, and then calculated the variance. So if you need this to look at potential individual differences or manipulation differences, and you can calculate each easily like that. All right, step 2, outliers and anomaly test using Explorer. So you know what to do. Explore. Then move all variables for repeated, right, to dependent variable. And I have exactly the same sample on the lecture slide. Statistics, you want to check outlier by each level, say yes. Plot, you want to do normality test, say yes, of course. Then options, not much. Then you say, paste it. I'm going to run it. Then all, skewness, kurtosis, their means, and then other descriptive stats, extreme values, whether you have anything that you need to worry about by group, test of normality. Oh, none of them are significant. Normality QQ plot to give you an idea. No outliers here. No outliers, another one. Third, repeat, no outliers. And the last repeat, no outliers. So pretty good output, right? So that's the way to go. Now, step 3, repeated measure, one-way ANOVA. So there are 1, 2, 3, 4 steps, which I will show you on SPSS shortly. But remember this here, contrast, you could use a contrast to look at post hoc here. However, if you use already planned contrast option, it doesn't give you full combination differences. So I want you to use for post hoc EMM method, estimated marginal mean method. If you know how to customize contrast, however, you can still use it. Okay, so I'm going to show you on SPSS. So here is our data. So I'm going to go to Analyze, GLM, repeated measure this time, then change. We need to define our repeated measure, telling the computer these are repeated. So it could be factor by default, but you can say animal, right? Then level 4, then you define it. Then now you need to define those, right? So move one at a time. Kangaroo testicles, and the fish eyeball, and the witchery group, and 4 groups, all repeated within subject. Then now model, we don't have much to do because it's one repeated, so we don't have anything to set. Contrast, you could still use it, like I said, and using one of these pre-planned one, but it doesn't give you a full combination. That's why if you don't know how to use this, the skill level is not still there, then we will use EM method using estimated marginal mean method, okay? So I'm not going to do it here. So I just cancel it. Then plot, you can say animal and a move, edit. Then line chart so that it can show you trend over time, and including error bar. Continue. And a post hoc you will see disabled. So it doesn't give us option like ANCOVA. Remember ANCOVA, we didn't have this option. So for the post hoc, we will have to use the estimated marginal means. So animal, move to display means for, click this. By default, remember this one gives you what? By default, paired comparisons, right? That is the source of our post hoc test. Then we'll use most conservative one, which is Bonferroni. Then save, we don't use any anything, and options. So let's ask descriptive stats and the effect size, and then continue. Then paste it to build your program, and then I will say, Okay. All right. So now you have the results to go over, which I also put step by step on the lecture slide. All right. So I'm going to use a lecture slide, move up here, starting with Mochilis test of sphericity. Okay. So Mochilis test came out significant. This is a p-value with Mochilis W value 0.136 chi-square, then what? Significance, right? If it's a significant, then it violated assumption. If it's violated assumption, then instead of reading, there's a next page, a next table in the output, it is ANOVA, repeated ANOVA table. Then do you see that sphericity assumed? Which means it was insignificant, then we can still read this output, but it was significant. So we cannot read this sphericity assumed output. We need to go either a greenhouse glacier, GG, test, or estimate, or Hyun-Feldit, which is all their last names of those statisticians, HF estimate. We can read one of them. Oh, when do we read GG? When do we read HF? I have some guidance here. And particularly when you have a conflicting significance. GG estimate was not significant. However, HF, which is a little bit more conservative, came out significant, right? So then, oh, what should we read? Of course, you read this too. If HF estimate their epsilon, what does that mean in an epsilon? Go back to Mochilis test output. These are epsilons. Do you see that epsilons? Hardly ever see people reporting lower bound estimate. Okay, so either GG or HF epsilons, and if this epsilon is greater than 0.75, then in reporting HF estimate is better. If epsilon of GG is less than 0.75, then reading GG estimate of a sphericity is better. Okay. Also, they say one is a significant statistician. I'm saying they say statisticians says if we get conflicting results between HF estimate and GG estimate, then look at multivariate test. And whether it's significant or not, then you make a decision as a researcher which one to report. So I looked at multivariate test here, then look, it was a significant. Which one to read, either lambda or pilaris trace? You decide which one is better. I see either way is actually, if both of them are significant at p-value this much, then you go, either of them is fine. So let's go with Wix lambda, then it's a significant, then you go back your the repeated major ANOVA table. Okay, then I'm going to take HF. It's a significant. So there are significant difference between 4 different trials repeated. Then when we are looking at post hoc, we are not looking at contrast. Post hoc is not even option for this. So we will have to use the EM method, right? Estimate marginal mean, which produce automatically pairwise comparison. Then you will see level 1, 2, 3, 4, 2, 1, 2, 3, 4, all combination comes it out so that you can take a look. So based on this, what did you say? Stick insect, which is number 1, took significantly longer time than other triers, and it was not significantly different with cherry grub eating. So that shows right here. Insect here compared to significant compared to significant compared to 4, which is with cherry grub tasting it. Not significantly different. And then there are other combinations that you can take a look to make it your conclusion, right? So going back to SPSS output, descriptive, multivariate test that we can use to make it our decision. And anyway, you need to report this, okay? And a match list test, GG estimate, and HF estimate, absence. If it's greater than 0.75, you read it. Less than, read a GG method. Then if you are still conflicting, you go back to multivariate test and make a decision as a researcher which is better for you. Then again, this is ANOVA repeated measure table. Spears assumed it was not in this particular data, so we have to report either GG estimate or HF estimate. And you don't have to worry about this test of within subject contrast. Then now going down, estimated mean, estimated marginal means, pairwise is right here so that you can look at what post hoc differences as we requested. Figure, as you can see, number 1, insect stick takes longer time than all these two, but not with number 4. All right, so which takes the shortest time to retch? It is number 3. It's a fish eyeball. Tasting it. Interestingly, culturally, in some cultures, when they have a fish as their main dish, they eat eyeball first. So it's what are cultural differences here. All right, that's it. So when it comes to how to report, all right, I'm moving down here. How to report. This is a comprehensive one, how to report, but because of its slight complexity of this report, I broke it down. Like how to report, descriptive, then what to report from which table, what to pick up right here, then how to report, comparisons, and then as you can see here, multivariate used reported a Philaris trace instead of a Wilks lambda, then followed by post hoc test, which was generated using estimated marginal mean option. Then figure as we requested came out, so we include here to show repeated major differences. And utilizing what you learned, right, and repeating that analysis, when you feel comfortable, move to statistic 11 with the new data set to apply what you learned from this lesson to this assignment.